Very good morning to one and all persons here. Good morning to all. So I hope all of you are doing well.
Good morning, sir.
Good morning, ma'am. Okay. So I hope all of you completed your inter assessment examination one. So you are getting some ideas. Okay. So how to write the exams and how the questions may be in RS in the data structure subject. Okay, and how it is to be solved like that. Okay. So based on the evaluation, okay, so I corrected some of the papers of you, and based on the evaluation, okay, I found that some people are done well, okay, and some of the people are writing something. For example, if you are writing for the answers for the question, for the long answer means, okay, so for the long answers they are writing only some of the half page or one page like that. Okay, so if you are writing like that, okay, it is not possible to get the good marks. Okay, it is not possible to score the good marks. Okay, so if some question is asked, okay, for example, I asked one case study, okay, in part C, like the one of the case studies something, but one is the concept of stack, another one is the concept of Huffman coding. Okay, but for answering that questions, okay, so some people are simply writing, so what is a stack and what are the operations in a stack like that. Okay, so it is not like that. Okay, you have to answer the questions for the questions completely, like you have to write the definition of first from the case study you understood. So what is the problem why they are given, and from the problem what is the solution you are finding the solution, and what is the way to solve the solution like that. Okay, you have to tell, and after that you will give the definitions for a stack, and you have to give the operations of a stack. Okay, and you have to write the routines for a stack like that, and followed by you have to write the yeah, just like applications of stack like that. Okay, so if you are writing like that only, you will get the 14 marks, full 14 marks. Okay, so if you are not writing in a like that means, if you are writing in a simple definition of a stack or simple procedures for a stack means, it is not possible to score the good marks or the full marks. Okay, so you should take care of this thing. Okay, you should take care of this thing, and you should aware of this thing regarding this. Okay, and for some of the questions like concept of single linked list and doubly linked list. Okay, so for the single linked list and doubly linked list, so some people are writing the definition of single linked list and doubly linked list like that, and followed by they are writing something called as the definition of linked list, and followed by some they are drawing something and they wrote something like that. Okay, so for the single linked list you have to write the routine also. Okay, you have to write the routines, so how to form a single linked list like that. You are getting something some of the simple routines, okay, from the internet, and you have to take it from that also. Okay, so if you are writing that thing, you will get the full marks. Okay, ma? So these kind of things are to be taken care of, okay, while writing the examinations. Okay, and followed by your presentation. Okay, so if you are writing something like that means, okay, you have to write the things full thing in a 1 or 2 pages like that. Okay, so only you are going to get some good marks. Okay, then so that is the thing what I observe in your internal assessment papers. Okay, so on continuation with that, we are going for the next topic. Okay, so can anyone can say, so what is the topic we discussed in the last class? What's the topic we left out or we discussed in the last class?
Huffman coding, sir.
Okay, so in the last class we discussed about Huffman coding. Okay, so I hope all of you understood. So what is meaning for Huffman coding is, so it is one of the technique to transfer your messages in a compressed manner. Okay, and the transferred messages are should be transferred without the formation of any inconsistencies. It means if you are going to send some data to the receiver, the receiver could get the data in a compressed manner without any loss. Okay, so the Huffman coding based on the concept of lossless compression, and for framing the Huffman coding and writing the Huffman coding, we are going for one thing called as Huffman tree. Okay, so with the help of the Huffman coding, we are forming a Huffman tree. So the Huffman coding structure might be stored with the help of Huffman tree, and the data may be arranged in the format of trees, and it is to be followed further. Okay, ma? So that is the thing we discussed in the last class. Okay, so in this class we are going to see one new topic. So it is called as graph data structures. Okay, graph data structures. So before going to that one, So can anyone say where you found this kind of thing called as graphs? So what is a graph? What is a graph? What is a graph?
Sir, pictorial representation of data.
What more?
Pictorial representation of data.
Okay, very good. Okay, it is a pictorial representation of an operations. Okay, it is a pictorial representation of an operations, or it is a pictorial representation of a some process. Okay, so that is called as a graph. Okay, so I hope all of you saw about the mathematical graphs. Okay, while studying your 10th or 12th standard, you are drawing some of the graphs like that. Okay, so how many axes are having graphs? How many axes are having graphs?
2, sir.
Two axes. Okay, it is having y-axis and the x-axis. Okay, so the opposite side of the axis starts from always x dash, and the other side of the y is also starts from y dash. Okay, so that is the two thing we have seen in the normal graphs in mathematics. Okay, so apart from this, we are having some thing called as graph. So in data structures, so in this graph data structures, we are going to see how the data are arranged in the format of graphs, and what is the actual nature of graphs in a real-time data structures. Okay, so that is the thing we are going to see. Okay. So before going to that deeply, okay, basically, a graph is nothing but a connecting points. Okay, graph is nothing but a connecting points. It may connect some number of edges, and it may connect some number of vertices. Okay, so here the meaning for vertices means it is some different parts of the thing which is having. The meaning for edges is nothing but it is to connect the one part with the other part. Okay, so I hope all of you know about uh, the concept of trees. In the trees, we are having nodes, and for connecting the nodes, we are having some edges. So likewise, in our graph data structure also, we are having some nodes. So all the nodes are connected together with the help of edges. Okay, so that is the basic difference of this one. Okay, and in a tree data structure, so the data are arranged in a format of hierarchical order, but in a graph it is not like that. It may be arranged in a some of the random orders. It is no proper structure for a graph. Okay, so on being this thing, so we are going for the concept of graphs. Okay, so I will share the screen, and from that we will know. So what is the definition of the concept of graphs? Okay. So whether the screen is visible to all? My screen is visible. Whether your screen is visible to all?
Sir,
Why is it visible?
PPT is not visible.
Anyone can answer?
Sir,
PPT
PPT is
not visible. Okay. Now,
no, sir.
oh, now is it visible?
Yes, sir.
Now,
Yes, sir.
okay, wait. Okay.
Yes, sir.
So now we are going to see about the concept of graph data structures. Okay. Let's take a social network. Okay. It may be a Facebook, or it may be a LinkedIn. It may be a something called as Orkut. Okay, like that. So that includes, always it includes some people's photo, and sometimes it may consist of some albums, and sometimes it may consist of some group of people. It may consist of some different pages, and it is having some the space for writing the comments, and some space for writing the stories, and there is some link for writing the note like that. Okay, and all. So it is a general thing which is mainly available in any kind of social networks. Okay, so let us say, so how how the user's photo is linked with some other people's network, and how it is to be merged together with the other different pages. Okay, how a story of a person is linked together with his account, like that. Okay, so all these things, okay, for example, maybe username or password or login ID, or maybe a photo, or maybe any album, like that. So all the things are linked together with something. Okay, so that is one type of relationship. Okay, so like that. So every relationship in this Facebook or social media, it may be anything, or is a format of some node to node link, which is formed with the help of an edges. Okay, so whenever you are going to create or add a new person to your already available Facebook account or anything, okay, a new link is created and that people is to be added with the particular account. Okay, so that is the thing which is given here for your understanding purpose. நான் சொல்றது புரியுதுங்களா? So how these things are linked together with the help of all the things without any interferences or without any strong disturbances. Okay. So for that, there is one thing which gives a solution for our thing is nothing but a graph data structures. Okay. See, so it is the structure of a graph which is given here. Okay, so a graph is nothing but a collection of vertices and edges. This is a collection of nodes and edges. Okay, sometimes the vertices may be called as an nodes. Okay, so graph is nothing but a collection of nodes and edges. Okay, so you see in the picture. So the symbol which is shown in this form of a circle, okay, are called as nodes in a graph. So how many number of nodes are there in this particular graph which I am showing in the screen? How many number of nodes and edges are available in the screen which I am showing here? Anyone can reply? Okay. So here we are having 5 nodes. Okay, so the nodes are named as here the node 0, node 1, node 2, node 3, and node 4. Okay, so see here all the nodes are joined with the help of one line. Okay, I hope all of you seen the line. Okay, so this line, okay, is called as edges. It is called as edges in a graph. Okay, the next one is vertices. So here the representation 1, 2, 3, 4. Okay, like this. Okay, so this symbol is nothing but a vertices in a graph, which shows the graph vertices. Okay, so that is the definition of graph also. Okay, so graph is nothing but it is a pair of vertices or set of vertices, and it is connected together and it forms a link together. So it shows an linked network for the transmission of or storing the data. Okay. So the graph may be represented in a mathematical format. Okay, so the mathematical formulation for representing graph is nothing but what you are seeing in the screen. So here the G represents graph, the V is nothing but a vertices, and E represents edges in a graph. Okay. So see here, so in the graph, and the V represents the vertices, so the E represents set of edges. So the E is nothing but it is made up of pair of elements from V. Okay, so the pairing of the vertices forms an edges. It means simply for linking one edge, one node to the another node, or linking one vertices with the other vertices, we are using a thing called as edges. Okay. The next one. So next one is types of graphs. Okay. So these are some different types of graphs which is available in a data structures. Okay. So see here, it is a graph. Okay, which is a disconnected graph. Okay. So see the picture. So first three nodes are connected, and these two nodes are connected separately, and the node one is remain separate. Okay. So this kind of nodes. Okay, a graph which is having no continuous links. Okay, or no continuous edges. Okay, is called as disconnected graphs. Okay. Then go for the next one. Here we are having some number of edges and vertices. So all the edges and vertices are connected together. Okay. So this kind of graph is nothing but connected, and two types of graphs. One is called as a directed graph and undirected graph. So in the undirected graph, so see here, if your graph is a directed graph means you are having the arrow heads. Okay. If your graph is a directed graph means the edges of the graph might consist of the edges. That means consist of some arrow heads. Okay. So if our graph is not an undirected graph means, so see here there is no vertices. Okay, there is no arrow heads. The next one, you see here, there is nothing but a interconnection of all the nodes with all the nodes. It means all the nodes in a graph are connected together to all the nodes. So this kind of types of graph is nothing but complete graph. It provides a complete graph. Okay. So see here, a graph which is continuously moving from one place to another place without any spaces or without any disconnection. Okay. So this kind of graph is nothing but a cyclic graph. Okay. A graph without any disconnections, okay, or any interconnected links. Okay, so this kind of graph is nothing but a cyclic graph. Okay, so see here, next one is a acyclic graph. So here we are having some disconnected process. Okay, so see here, so in this graph the red color marked node, okay, which is a node which is to be disconnected from the particular graph. Okay, this is a disconnected graph. So in this kind of graph, there is no cyclic format. So this kind of graph is nothing but an acyclic graph. Okay, so it is very important. So there are some different types of graphs available. So among the different types, we are having this kinds of things. Okay, one is disconnected graph, then connected and undirected graph. The next one is connected directed graph. The next one is complete graph. The next one is cyclic graph. The next one is acyclic graph. Okay. Then apart from this one, we are having based on the weight, okay, or based on the cost value, the graph is classified into two things. So one is, for example, so see here, one is called as weighted graph and another is called as unweighted graph. Okay. So let us consider an example. For example, you are considering the A is the location where you are staying here. Let us consider the B is the location where you are going to move. Okay. So let us consider they are giving some value called as 3 now. Okay. So let us say you are traveling from the place A to B. From the place A to B, you are going with something called as, for example, if you are going to travel with the help of bus like that. Okay. So for the bus, you are going to pay some ticket. Okay, that the rate of ticket is nothing but a 3. Okay, So this kind of things, okay, this kind of value marked among these two things represents the cost of the graph. Okay. Sometimes it may be taken as distance of the graph. Okay. So okay. Then followed by this thing, I'm going to say, so the link representations, okay, how the link representation is done with the help of graphs. Okay. Okay. So in a graph, okay, in a graph, maybe a weighted graph or unweighted graph, maybe directed graph or undirected graph. Okay, you are having one thing called as adjacency matrix. Okay, we are going to form one matrix called as adjacency matrix. And what is the meaning for adjacency matrix? Means it gives the relationship of a particular node with the other particular node in a graph in your given representations. Okay. So what is the meaning for adjacency matrix? Means it shows the self-representation node. Okay, so in the same node can represent the same thing among its referential integrator. Here it is called as the key. Okay, that is the linking key. Okay. Then, so let us consider this graph. Okay, so for this graph, we are going to form the adjacency matrix. So how the adjacency matrix is formed is, listen. So you got to consider all the nodes. Okay, you got to consider all the nodes. You got to form a matrix-like structure. So all the nodes are represented individually in a row wise and also in column wise like this. Okay, all the nodes are represented in a individual manner in the format of column wise and also in the row wise. Okay, you see here, let us consider the representation of adjacency matrix for the undirected graph. Okay, so let us consider a node A. Okay, let us consider a node A. Okay, let us consider a node A. Okay, so for this node A, for this node A, is you have to check whether there is any relationship between the node A to node A. Okay, so see here, you have to check whether there is any relationship between the node A to node A. Okay. So there is no relationship between the node A to node A. Okay. So how you are saying it is there is a relationship between the node between these things means, if it is like this, okay, see here, if it is like this, if there is any self-representation for a particular node, it is called as relationship. Okay, so if it is like this, then you have to mark 1 here. So actually it is not like that, so you have to mark it as a 0. Then you have to check for if there is any relationship between the node A and to the node B. So you see here, yes, the node A and the node B are linked together with the help of edges. So you have to mark it as 1. Okay. Then next, you have to check for the node A with node C. So if there is any relationship between the node A and node C, yes, the node A is linked together with the node C with the help of a link like this. Okay, so now you are marking this node C as 1. Okay. The next you have to check whether the node A is linked with node D. Okay, whether the node A is linked with node D. Yes, the node A is linked with node D with the help of one link like this. Okay, so you are marking it as a 1. Then now you are going to check from node A to node E. Node A to node E. So there is no direct relationship between the node A and to node E, because the A is directly connected to B, the A is directly connected to D, the A is connected to C. So the A so it is the thing. Okay. So see the picture. If there is any link between one node to another node, first you take A. So if there is any link between A to B and A to C, A to D means you have to mark it as 1, 1, 1 to the particular node which is having the link together. If there is no link between one node to the another node, so that is to be marked as a 0. So likewise, you have to mark for all the nodes. So now you see the node D. So why, how the relationship is marked to the node D? It means, for example, node D to node A. It is, there is some link, it is 1. Then node D to node B. Is there is some link relationship, it is marked as 1. Then node D to node C, it is marked as a relationship 1. Then node D to node D, because it is marked as a 1. Why means it is having some self-reference node D. So it is to be marked as an 1. Then followed by we are having the representation, the node E to node E, node D to node D, it is 1. So node E to A, there is no direct relationship. It is marked as an 0. Then from node E to B, there is some direct relationship. It is marked as an 1. From node E to C, it is marked as an 0 like that. Okay. So likewise, it is going on. Okay. The undirected graph. For the undirected graph, the adjacency matrix is going on like this. Okay. Then see below, we are having another image. Okay. So it is the image for a directed graph. Okay. So now you check the adjacency matrix for a undirected graph, undirected graph. Okay. So whether both are same. So it is not same. Okay. So you have to do the process like this. Okay. So like this. Okay. Whether the arrowhead moves from which node to which node. Okay. For example, if a node moves from A to B means, so for A to B, you got to mark it as a 1. Okay. For this A to B, you got to mark it as 1. The next you check for the node, the link from A to B. Okay. A to B, which represents that relationship, so it is named as 1. The next you check it for the node A to C. So the A to C, there is some direct relationship, so it is to be marked as 1. So that's all. Okay. So it is having some direct relationship with the help of arrowhead. It is marked as an 1. Likewise, you got to check it for B. So there is some direct relationship between the B to E is 1. The next one, B to D is 1. So there is no direct relationship between the B to E or like that. So check for this D. So for this D, there is some self-referential node. It is called a self-referential node because the D itself refers to the D. So it is to be marked as an 1. Then D to A. Okay, it is marked as an 1. The next one, D to E, it is marked as an 1. For simple understanding purpose, for the directed graph, you got to simply take this idea. So if a node is having any outgoing edges, okay, if a node is having any outgoing edges, so that is to be marked as an 1. For example, the D is having the outgoing edges for the node A and the node E. So it is to be named as 1, 1. Okay. So further it is followed like that. Okay. So now all of you take this as an example and find the adjacency matrix for. So all of you find the adjacency matrix for the given graph now. So all of you solve this adjacency matrix for a given graph. Find the adjacency matrix for a given graph. How many nodes are here? We are having 5 nodes. So here also all the 5 nodes are linked together with the help of edges. and for these nodes there is no values. It means religion the incident matrix represents. So it shows there is some link to the particular node in a direct manner or in a reverse manner or in a vice versa manner. Okay. So that is to be solved with the help of this incident matrix. So see here how it is different from incident matrix. Okay. So in the incident matrix, the edges are named as some values. Here, the edges are given as E1, E2, E3 like that. Okay. So, so for forming instant matrix, you have to write the edges value in the row wise, and you have to write the node values in the column wise, or in a vice versa, any manner. Okay. So there is no problem if you are writing the edges in the row column wise or writing the nodes in the column wise. Okay. So if you are after you write this thing, okay, after you write this thing, then you have to form a matrix structure like this, and you have to see whether is there is any link which moves from node A, or if there is any link which is moves, that is you have to check whether here incoming edges and outgoing edges from node A. If you are having any outgoing edges from node A, that is to be marked as 1. You see in the picture, this clearly shown. So if you are having any outgoing edges from a particular node, here I am saying A. So from the particular node to the next one, if you are having E1 means there is some outgoing edges, E1 means it is marked as 1. From the node A, you are having an outgoing edge that is called as E2. So it is to be marked as 1. So you see here, there is one incoming edges for the node A. Okay. So if you found the incoming edge for a node, so we mark 1. Okay. So that edge is dead or noted So which one shows the example for directed graph and which one shows the example for undirected graph? So see here, the picture one shows the representation of a directed graph because here we are seeing the Google map, which always shows the direction for a particular people from moving from one place to another place like this. Okay. So see here, in the another graph, we are having the same thing, but here they are giving something called as the distance from one node to another node. For example, here they are mentioning 7 miles and 5.4 miles. Okay, and here they are given as 1 miles like that. Okay, so it shows the distance of the people who is moving from one place to another place. Okay, so the basic difference is the first one shows an undirected graph, then this one shows the undirected graph. Okay. So that is a thing which I want to insist here. So based on this, you are going to get some important things. Okay. So some of the applications, okay, these are some of the applications of graph in real time. So this graph may be used in the concept of social media. It is used in the concept of LinkedIn. It is mainly used in the concept